So these are a set of exam questions that are all about ASCII or Unicode or both. So coding systems. So ASCII, which they've told us is American Standard Code for Information Interchange. We should know it's a 7-bit code which represents characters. It's quite an old system now, but because there's 7 bits, that means we've got 128 different characters to represent. Now the first question, it's a shade the lozenge idea. So they're telling us that A is 65, and all I want to know is what 70 is. So let's just write the numbers down. 69, 70. And ASCII and Unicode follow on. So A, B, C, D, E, F. It's a capital A that we've got there. So 65 to 70. So the answer is going to be F. I'll shade that lozenge. So there's a few things they've tried to do to confuse you or put you off the scent a bit by putting a lowercase f in, an E as well, because if you just miscalculated, you might arrive at that. So this is a really safe way in the exam of making sure you always get this answer correct. Just write the numbers down. It's no problem. There's space on the exam paper. You don't have to do everything in your head. So then we've got another question here. Unicode is an alternative to the ASCII coding system. One advantage and one disadvantage of Unicode to represent characters. Well, Unicode is usually 16 bits, could be more. But if there's 16 bits, then there's 65,536, I think, different characters. So we could say an advantage is, more characters can be represented in Unicode. And we could say because it uses more bits per character. A disadvantage because more bits are used, the message is larger, takes longer to transmit. So that's a perfectly good answer for that. You could say that because there are more bits, it takes more storage. It does take more storage, but these days storage is not so expensive as it used to be, and we're more interested generally in transmission times, but either of those are still a fine answer, no problem. So the next one we've got is every ASCII character is stored in a computer system as a bit pattern. State the maximum number of bits required to represent any of the 128. Well, we know it's 7. So ASCII is a 7-bit system. And if you want to prove it to us, we could write the numbers down. So there's our 7 bits. And if we add all these together, we get 127. And of course, we've still got 0. That's 128 different characters. How many extra bits will be required to represent a character in ASCII if the number of possible characters was extended from 128 to 256? The answer to that is just 1, because we just add 1 more bit on the end, 128. And we probably remember that 8 bits is 255 if they're all 1s, and we've still got 0, so that's 256 different characters. So that's just 1 bit extra there. So this question is about true and false. So false, which is a false statement. So ASCII stores each character code 7 bits. Well, that's true. We know that. It's a 7-bit code. ASCII can only represent letters in uppercase. That's false because we know it can do upper and lowercase. Character codes in ASCII are grouped together and run in sequence. They do, because we've looked at that in a previous question. ASCII and Unicode use the same character codes up to number 127. Well, that's true as well. So this is the false one. So we'll just shade that one in there. That's the false statement. Okay, so let's move this up a bit. Okay, so we've got another one here. ASCII is a character coding system that uses 7 bits to represent each character. Complete the table stating the representation of the character G. Well, we've got character F, so F and G follow on. So G is going to be one more. So in binary, we're just going to add 1 to this. So we're just going to add 1 to that binary number, and it's really easy actually because they've left us a 0 at the end, so that's nice. Incidentally, it's a 7-bit code, so don't represent this as a full byte. Don't put anything else in there, just the 7 bits, that's all we need. And we'll get our mark. If you add an extra character, you will lose the point, so please don't do that. Explain the possible limitations of using the ASCII character set for global communication. Okay, so global communication. What do we know about ASCII? Well, we know that it's only got 7 bits and therefore it's only got 128 characters. So we could say that first of all because we can prove that we know something. So let's say that ASCII uses 7 bits, so has a limit of 128 characters, which is probably a good thing to start off with. These characters represent 1 alphabet. Sort of English, or American English if you like. So we would call that the Latin alphabet, but most of us recognize this as English. So this means characters from other languages cannot be represented using ASCII. So we could say languages, we could say alphabets there, but there are other languages that use different alphabets is what we're trying to say. We're going to get away with that, that's going to be fine. So we could give an example if we wanted to. So we could say, for example, the Chinese language or the Russian or Cyrillic alphabet. We could do that if we wanted to be really clever, but we've said enough to get our points. We've said that ASCII is 7 bits and so has the limit of 128 characters. That's going to give us a point for this. This allows us to represent 1 alphabet, and we've said English, that's fine. We're going to get another point for that. So characters from other language cannot be represented. It's going to give us another point there. So we've got 1, 2, 3, 4 points that we've got there. So the 7 bits and the fact of the limit of characters gives us the 2, and then the idea of representing 1 alphabet and not being able to represent other languages gives us the other points.